Welcome to this video lecture. In this particular video lecture, I'll be discussing about block diagram reduction technique. So the topic which is being covered in this particular video lecture is a numerical based on block diagram reduction technique. So let us consider this example where we can understand how this complicated block diagram can be reduced into a simpler one by making use of block diagram reduction techniques. Obtain transfer function by using block diagram reduction technique for the block diagram shown below. So in this particular block diagram, if we observe, there are three summing points: summing point 1, summing point 2, and summing point 3. R is the reference input which is being given. C is the controlled output which is being taken. And in the middle, we have different blocks consisting of its own transfer function. So using this particular block diagram, we have to reduce this block diagram such that we get a single transfer function. So clearly by observing this block diagram, we can come to a conclusion that block G1 and block G4 are connected in series. So when two blocks are connected in series, the equivalent transfer function will be the multiplication of the transfer function of each block. That is G1 multiplied by G4. So if we observe, this G1 and G4 are connected in series. Hence, the equivalent transfer function of this will be the multiplication of individual transfer functions of the blocks, G1 multiplied by G4. So once we reduce that, the block diagram looks somewhat similar to this. G1 into G4 is the newly obtained transfer function after we reduce the series blocks. Similarly, if we observe, block G2 and block G3 is connected in parallel. The signal is getting diverted here if we observe. So when the signal is getting diverted here, means the signal which is traveling between G2 and G4 is completely different. So when the signal between these two blocks are not same, then those two blocks are connected in parallel. So G2 and G4 are connected in parallel, and we have a sign in a summing point called as positive sign. We have a positive sign here, which indicates that we have to algebraically add these two blocks. So when two blocks are connected in parallel, we have to either add or we have to subtract based on the sign. So because we have positive sign here, we'll be adding it. So the equivalent transfer function for these two blocks which are connected in parallel will be G2 plus G3. Because G2 and G3 are connected in parallel, the equivalent transfer function will be G2 plus G3. Now the block diagram looks somewhat similar to this. If we clearly observe, we can get to know that we have a canonical form of control system over here, or minor loop is generated. A canonical form of control system or simple form of control system is a kind of control system where we have one summing point, one takeoff point, one block in our forward path, and one block in our feedback path. So that kind of representation is called as canonical form of representation or simple form of representation of a block diagram. It is also called as minor loop. So we can spot a minor loop in our block diagram. We already know the formula how to reduce this particular minor loop for its equivalent transfer function. So the transfer function for this minor loop will be equal to transfer function is equal to g of s divided by 1 minus g of s into h of s. Transfer function of this minor loop will be given as g of s divided by 1 minus g of s into h of s. Because we have a positive sign in the feedback signal over here, in the formula we'll be getting negative sign. If we had negative sign in our feedback signal, in the formula we would have got positive sign. So this is the formula which we will be using to get an equivalent transfer function for this minor loop, where g of s is the forward path transfer function. Here in this particular example, g of s is g1 multiplied by g4. H of s is the gain or transfer function of the feedback path. Here h of s is h1. So when we substitute g of s as g1 into g4, h of s as h1, we will get the equation as transfer function of minor loop will be equal to g1 into g4 divided by 1 minus g1 into g4 multiplied by h1. Now the block diagram looks somewhat similar to this. If we observe here again, two blocks are connected in series. G1, G4 divided by 1 minus G1, G4, H1 is connected in series with G2 plus G3. The reason why these two blocks are connected in series is if the signal is being transferred between these two blocks, there is no deviation in a signal. The signal cannot take any other path. So the signal should travel through both these blocks. Same signal has to flow. Hence, these two blocks are said to be connected in series. So when two blocks are connected in series, the equivalent transfer function will be multiplication of individual transfer function blocks, transfer function. So because these two are connected in series, the equivalent transfer function will be equal to G1, G4 into G2 plus G3 divided by 1 minus G1, G4, H1. Again, if we observe over here, we have a minor loop or canonical form of control system, which consists of one summing point, one takeoff point, one block in our forward path, and one block in our feedback path. So this forms a minor loop. Because we have a negative sign, to find the transfer function of this minor loop, because we have a negative sign in our feedback signal, in the formula, we'll be getting positive sign as follows. So transfer function of minor loop will be equal to g of s divided by 1 plus g of s into h of s. The reason why we have got positive sign here in our minor loop formula is because the signal which we have got here is negative. Now, g of s will be equal to g1 g4 into g2 plus g3 divided by 1 minus g1 g4 h1. H of s will be equal to h2. So once we substitute it, we'll get this equation. Next, what we'll do is we will cross multiply 1 minus g1 g4 h1 here. So when we cross multiply and when we simplify, we'll get this 1 minus g1 g4 h1 and 1 minus g1 g4 h1 will get cancelled. Finally, we'll be left out with a transfer function g1 g4 into g2 plus g3 divided by 1 minus g1 g4 h1 plus g1 g4 into g2 plus g3 into h2. This is the final result which we require. I hope that you have understood this video lecture. Thank you.